have to explain. Okay, so for the x and y, I put the 8 to the y for the first, and then the x I put 1, and then the 7 I added them together, and they equal 8. I did the same thing for the second one too. I put the 8 to the y, 6, and the 8 would be, the x would be 1, and then I times 6 times 2, and I added 2, which is plus 6 times 1, and I added 2.
Okay. Who else used this method of putting x and y in and seeing are they both true statements? I know there were a couple of us. So that was one method. Anyone use a different method? Aaron. Okay, walk me through that.
I put x plus 7 in for y.
So if you didn't do this method, listen, because this may be not new because we did this last class, but a good refresher. So then from there,
X from each side. Subtracted 7 from each side. And then it was 5x equals negative 5x equals negative 5. And then x equals 1.
that shows we have the first part, and then how would we get the second part?
You would put 1 in for x, where x equals plus 7.
You're so funny.
Right? So this was another method that you could have used, the substitution method. Who else used substitution? Good. And then there was one last method, graphing. You could have used Desmos or the calculator. Did anyone use the graphing method? No. Remember that that's always a good double check. Put it into Desmos really fast, see where they intersect, and then if that is the intersection point, that would be your answer. But to all of us that got that this was a solution, good job. There we go. Alright, so today we're going to talk about the last way to solve systems of equations algebraically by elimination. I'm going to have you fill this out real fast on the notes that should be in front of you. The elimination method. You add or subtract or multiply and then add or subtract to eliminate a new variable. Matt, come back up to your seat. Step 1, make sure the equations are lined up. Step 2, add or subtract the equations to eliminate the variable with common coefficients, the number in front of the variable. And then step 3, solve the equation for the remaining variable. Step 4, substitute your answer into either original equation and solve for the other variable. So step 3 and 4 are very similar to your substitution method, where after you get one of the answers, you put it back into another equation and figure out the other answer. But the original part, the step 1, step 2, those are different. And then we're also going to talk about what happens if we don't have common coefficients, and that's what this note is about. There aren't common coefficients. We're going to multiply to make them common, but we'll see how we do that here in a moment. So once you finish writing this down, we're going to move on to the next example. going to do together about six problems, and then any other problems you want to see go over, have questions about. So we're going to start with number 1. If these boxes are not enough space, feel free to get more paper, do it somewhere else. You don't have to do it in the small little box. So your first step is always to make sure everything is lined up. So when I say that, the y's line up on top of each other, the x's line up on top of each other, the equals lines up on top of each other, and the constant lines up on top of each other. If that is the case, that box is checked. You don't have to do anything. So that is the case for number 1. Then we're looking for, of the 2 variables, x and y, on both equations, which ones have the same coefficient, so the number in front of the variable. Of these 2, which one has the same coefficient? X or y? Say that again. Why? Because they both share a 1, you just don't see it. So since y is the thing with common coefficients, that's going to be what we eliminate, get rid of. And then you have to think to yourself, if I wanted to eliminate these, make them cancel each other out, what operation would I need to do in order to do that? So I'm going to put that out front, and I'm going to subtract the entire equations from each other. So y minus y would be 0. 3x minus x would give us 2x. And then be careful here because we have 2 negatives. 4 minus a negative 2 would be plus. So if you're not sure, put it in your calculator, double check it. And then our y is eliminated, it's gone. That will happen for all of these problems. One variable disappears. Both may later. And then we're going to solve this for x. How would we do that? We will divide, not first though. We technically in this case could, but that wouldn't help us yet. How would we get x by itself? Very long. And then, Elijah, we would divide. So we have one part, we have our x, we still need to find our y. So this would be like our step 3 or 4, where we take this x and put it back into one of these equations that were given, does not matter which one. So let's say I use the second one just because. So then we would find our y value, which is what? Aaron? Negative what? Negative 5. And then just as before, we would write this together as an ordered pair, x, y, negative 3, negative 5. And then just like before, box in that answer so we know that is the final, your final answer. Questions on that one? What questions do we have? Anything we're possibly confused on? Process the answer, any of the steps. So we're going to try number 2. The format is different, but that's okay, as long as everything lines up, which in this case it does. We have x's on top of x's, y's on top of y's, equals, and then our constant, so they do line up. And then of x and y, which one shares a common coefficient? X. They, again, both have 1. So then, again, you have to ask yourself, what would I do to these two to make them cancel each other out? Subtract. Again, most of the time you're subtracting, but there are sometimes you add. So again, we're subtracting both equations. Get in the habit of putting whatever you're doing out to the side. So, what were you going to say? Okay. So the x's would cancel. We'd have 4y minus a negative y, so 4y plus. And then 15 minus 3 would give us 10. I didn't put 0 here, but if you wanted to, so that you know that's where it went, you could. What I mean by that is this. You could put this, but you don't need it. And then we're just solving for y. And then just like the last problem, we would take that, put it back into one of the equations, does not matter which one, just solve for x. Let's say I put this in the second one. And then I solve for x, so add 2 to both sides. So then what would that final answer be? We have to write that as an ordered pair. Aaron. 5, 2. 5, 2. In parentheses. So far, do we have any questions about anything we've done? Everything making sense so far? The next one we're going to do is 4, but we'll do that when we come back from lunch. Okay. On 4, double check. Everything is in line. The x, the y's, the equals, the constant. Yes, so that checks. Of your x's and y's, which one has the same or a similar coefficient? Right, the x's. So because of that, we're not going to change that. We're just going to look at how would, or what would we do to these so that they cancel? What operation? Add them. The general rule of these is if the sign is the same, you're going to subtract. If it's different, you're going to add. If you're not sure or that rule is confusing, just double check in your calculator. If I did 4 plus a negative 4, that would give me 0. If I did 4 minus a negative 4, that would not give me 0. So whichever one cancels, that's the one I need to go with. So we're going to add the two equations together. We just found that 4 plus a negative would cancel our x's. 9 plus 7 would give us 16, y. And then 5 plus 11 would also give us 16. So we would solve for y. And then go back, put that in one of the two equations, does not matter which one, and solve. Let's say I do the first one. 4x plus 9 times 1 equals 5. And then I would start solving for x. multiply, and then get rid of the 9 by subtracting, and then divide. So then what would our final answer be?
It's an ordered pair. What should it be?
So then, I did see your hand.
Negative 1.
Negative 1, 1. As long as you remember to put your x first and then your y, you're good. As always, with all of these problems, you can go back and double check. So if you're practicing, use Desmos, put them in, see is that the intersection point. If this were like on a test, on a quiz, you could solve these two equations for y, put them both into your calculator, and then graph them, and see if you get the same thing. Do you have any questions with how we did that process, how we got that answer, anything like that? The next one we're going to do is 5. For a couple reasons. One, these aren't lined up. Like the x's are on top of each other, but the equals is not. So we either need to change this one so it looks more like this, or change this bottom one so it looks more like the first one. Either or. Which one would we rather change, the first or the second? Okay. So the second to make it look more like the first, which means we need to get rid of the y term by moving it over to the right. And I'm going to rewrite that. So it would be 2x, 3y equals 3y plus 10. If you want to rewrite the very first one as well so that they're together, you can do that. It's not necessary, but you can. So then looking at these two equations, do we have a variable with the same or a similar coefficient? The y. They both have a 3. So what operation would I do to this, or to these both, so that they would cancel? Subtract. So I'm not going to rewrite it, but I am going to write the minus out here, so I know I'm subtracting this and that. So negative x minus 2x would be a negative 3x. 3y minus 3y would give us 0. You can put the 0, you can leave it off, it doesn't matter. And then 11 minus 10 would give us 1. When we divide this, what happens?
Get a whole number, guys?
Is this a whole number? No. So this is another reason why I wanted to do this one, because you end up with fractions. That doesn't always happen, but it does sometimes. So you just have to pay attention, be careful. If you do end up with a fraction, I would say a couple things. If it's a nice enough fraction where you can change it to a decimal, like 0.5, 0.25, something like that, that ends, you can change it to a decimal and then go from there. If it's something that has a repeating decimal, just leave it as a fraction. And then afterwards, maybe check Desmos or check whatever so that you see, was this supposed to be a fraction or not. So I don't really have space to keep working in this box, so I'm going to do the rest of my work somewhere else. But then we need to find our y. A lot of the times when you have a fraction as 1, you'll usually have a fraction as both x and y. Sometimes that's not the case, but most of the time it is. I'm going to put it into the first equation, but I'm going to do that up here. So negative x equals 3y plus 11. This will become a positive 1/3. And then we would solve it for y, just like a normal problem. We just have to deal with the fraction. So subtract 11. And you can do that in your calculator. Alpha y equals will give you your fraction. I was just writing that this is number 5. You don't need to write that one. So do that in your calculator. Tell me what that is. 1/3 minus 11. There. Negative 32/3. And then to get y by itself, you could do one of two things. Either divide both sides by 3, but you already have a fraction, so you're going to be dividing twice, really. Or you could flip the 3, change it to the reciprocal, and multiply that on both sides. What would your y value be? Negative 32/9. So then our answer is not going to look very nice. I'm going to write it up here. But it would be negative 1/3, negative 32/9. Both of those I would just leave as fractions, not change to decimals, because they're not nice decimals. That will probably be as complicated as this gets if you end up with fractions. Otherwise, the process will be the same. I may have misspoke a little bit, but that's okay. Do you have any questions, confusion about anything from that problem? Right, and then we're going to do 2 more. And then any others you want to see, go over, have questions about. Does anyone still need this up at the top? Look at number 9. Everything lines up. Do we have a common coefficient? In number 9? Are they the same? No. So in this problem, we can't just add or subtract them. If they're not the same, we won't get the right answer. We have to make one of these the same. It doesn't matter which one. So let's say I wanted to get rid of my x's. I would need to make them both have a 2. So what I could do is, since this is a 1, the only way this would become a 2 is if I multiplied it by 2. So I could do that, but I have to multiply everything by 2, so I'm not breaking any math rules. Because what I do to one side, I have to do to the other. So I'm going to change this equation completely. And I'm going to rewrite that underneath. 2x plus 6y equals 12. So we've changed the equation. Now do we have a common coefficient? Yes. The x's both have a 2. So what operation would I do here so that they cancel? Subtract. So I would subtract everything. 2x minus 2x, those would cancel. Negative 7 minus 6 would be a negative 13y. Negative 1 minus 12 would also be a negative 13. And then divide everything by negative 13. So that y equals positive 1. Then when we go back to find x, you have choices. You can put it into one of the original equations or the one we changed. It doesn't matter. As long as you do the math correctly, you should get the same answer no matter what. So I'm going to put that one into the first one. So x plus 3 times 1 equals 6. So x plus 3 equals 6. And then solve for x. So that x equals 3. And then that final answer would be 3, 1. Did how we get to the elimination process make sense? Yes, no, maybe. I see some yeses. Because you will need to be able to do that and notice that I have to change this before I can eliminate. Yes?
Can you also add it when you have to multiply it?
You mean at the beginning? Mm-hmm. You have to multiply first because they're not the same. We can't just add or subtract first because they're not the same. If they were, though, then yes, you could add or subtract. You understand why?
Yeah. Okay. I was just going to that's why.
Alright. There are 4, yes, special case where you get no solution or infinitely many. Those 4 are 7, 8, 11, and 14. We're going to do one of those and then more if we want to see another one later. Of those 4, which would we want to see right now?
7.
Okay. So starting with number 7. Everything lines up, so we don't have to worry about that. We have common coefficients for x and y. Then really you just have to ask yourself, are we eliminating x or y? Or which one would you want to eliminate first? Doesn't matter.
You pick one.
X, y. I heard x before y, sorry. Okay, so if we're eliminating x, what would we do? What operation would we do to get those to cancel? Subtract again. So subtract the entire equation. So the x's cancel. What would happen to the y's? Say that again. What were you going to say? They also cancel, correct. So you end up with 0 on this side. And then I could do this. Negative 10 minus negative 13 is really plus 13. Is this a true statement? No. So what does that mean? What type of solution is this? No solution.
You're on fire with it.
Yeah, right.
There's no equal on the top one, so we're gonna do equal 0.
Okay, so that was a typo. There should have been. That was a typo. But thank you for catching that, because my third period did not catch that. Alright, do we have any questions about that one? So you'll know really fast if it's no solution or infinitely many, because everything cancels. All the variables go away. And then you're either left with 2 different numbers or 2 of the same numbers. Right. So those are all the ones that I wanted to go over. Look at the remainder of this page and the next one. Find any you want to go over, have questions about, want to see how to start, anything like that. 10 on this page? Yeah, okay. And then I'll circle them and then we'll go through them. Any others? Someone? 13 on this page? Or on the, okay. 10, 13, Aaron? 8. Any others? 15 on this page? Go back. Alright, so let's start with 8 and work our way down. With 8, these are lined up, yes. We have common coefficients, yes. Do we want to eliminate x or y?
What do you guys want to try?
X, okay. So in order to get rid of x or make these cancel, what operation would we use? Let's try it. So I'm going to do 2 minus a negative 2. That would cancel it. So then we'd have to add it. Technically, we're subtracting, yes, but we have to think about what are we doing to the entire equation. So it's going to be addition. Also, these are different, so we're going to add. The adding part gets tricky. Just remember you're doing it to the entire equation and to double check it in the calculator. So then what happens to our variables? They both cancel, yes. Leaving just 0. Negative 10 plus 10 is also 0. Is this a true statement? Yes. So what type of solution would this be? Infinitely many. So again, you'll know real fast if it's one of those two, because all your variables cancel. Any questions on 8 before we move on to 10? With 10, they're all lined up. Do we have common coefficients? No. So then we have to make one. Do we want to eliminate x or y? You guys choose. X, okay. So then we have to think about a number we could change these both to. It could be the smallest number we could change them both to, a bigger number, it doesn't matter. I would say probably try to stay small because they could get big real fast. What's the number we could change these both to? It's like on the tip of your tongue to say. 15, yep. I was like, you were like forming the words with your mouth but not saying it. I was like, yes, 15. So we would change this first one by multiplying everything by 5. and change the second one by multiplying everything by 3. So we have 15x plus 15y equals 45. And 15x plus 12y equals 30. So we've changed both equations, not just one. Sometimes you'll need to do both. Sometimes just one is fine. It depends on the problem. So now we have a common coefficient, our x's. What would we do to eliminate them? Subtract. So 15 minus 15, those would cancel. 15 minus 12 would be 3. 45 minus 30 is 15. Divide everything by 3. So that y equals 5. Okay. And then you have 4 choices now to put this back into. The first, the original, or the 2 you changed it to. Does not matter. As long as you do the math correctly, it should all work out. So let's say I put this into the very first one. So 3x plus 3y equals 9. 3 times the 5 in place of y. We have 3x plus 15 equals 9. It's getting a little hard to see, sorry. Bless you. Subtract 15 on both sides. And then divide both sides by 3. Bless you. So x equals -2, y equals 5, and that would be our answer, our solution. Any questions, confusions with 10? With 13, everything's lined up. Do we have a common coefficient? Guys?
For number 13, right?
For 13, yep. Do we have anything that is the same? So then we have to pick and choose what we want to eliminate or make the same. Do we want to get rid of x's or y's? Y, okay. So if we're getting rid of y, it needs to be the same. Or, so we can multiply it by -2 or 2. That doesn't matter. I'm just going to multiply it by -2 just so we're consistent with everything else we've been doing. So that would become -2x minus 2y equals a positive 6. And then in order to eliminate our y's, what operation would we do here?
Add or subtract this.
If you're not sure, double check your calculator. This is a tricky one. Because of all the negatives. We are subtracting. But this is what would happen if we added. Say that one more time. 13. So -2 plus a -2 wouldn't cancel it. But if we subtracted you, really, if the signs are the same, if they're both negative or both positive, you're going to subtract. If one's positive and one's negative, then that's the only time you really add. So again, put that negative outside of everything so you know you're subtracting everything. 5x minus a negative 2x, that would really become a plus. And that would be 7x. Negative 2y minus a negative, again, that would become a plus, and those would cancel. And then negative 50 minus 6 would be negative 56. And then divide. And then again, you have choices where you want to put your x. I would put it into the first one because there's less solving. So negative 8 plus y equals negative 3. Add 8 to both sides. So we get negative 8, 5. Any question, confusion on that one?
Those who are zoning out and going to your phones, don't give in to temptations. Try to solve it while we're doing this, not waiting for the answer. Okay, because you might see things like this very similar on Khan Academy and on your quizzes.
Very good practice to start asking yourself the same questions I'm asking you. That way when you do it by yourself, you know what to look for.
Those negative positives and positives can be very tricky.
Anyone still writing this part down?
Right. Nice job for those who are participating. You guys are on a roll.
Alright, 15 on the last page. Our x's and our y's are lined up. What's our next step? Did you say add them? Okay. Are we eliminating x or y when you said that? Okay. Because that's important. Because in this case, because our y variable is exactly the same and our x variable is positive, negative, we could add to get rid of the x's, but it wouldn't get rid of the y's. Or we could subtract to get rid of the y's, but it wouldn't get rid of the x's. So we have to be very careful on that. Right, so add the two equations. Our x's cancel. Negative 2 plus a negative 2 would be a negative 4y. Negative 6 plus 2 would be a negative 4. What would y equal?
Negative 4 divided by negative 4?
1. And then what's our next step?
Well, we already got y, so what do we do about x? Which one do you guys want to solve instead?
Brian, what were you about to say?
Just solving for the first one.
For the very first equation?
Yeah.
Okay. So we would do what with this one in the first equation? Put it in place of y. And then solve. So to get x by itself, we would do what? And then so that x equals positive 2. And our final answer is Aaron, 2, 1. All right. So I have a game for you guys. It's a bingo game on systems. If you would rather not play and continue practicing Khan Academy, you can do that. I do have a prize if you play the bingo game though. Because we're running low on time, you can use Desmos instead of solving everything. I'm just going to have you write the problems down. That way you can go back and practice elimination, substitution later. Who all wants to play the bingo game? 1, 2, 3, 4. Okay. So if you do change your mind and want to play, you can. I have a bunch of bingo boards. Let's rearrange. If you're playing bingo, I just need you closer to the front. If you're not, do you want to play bingo?
It's got a prize.
Sure.
Okay. If you're not, you can move further to the back. Mariah, are you playing? Yes. And are you playing? No. So you can move to the back. Aaron, you can come up here.